All right, test. Okay, there we go. Sorry, y'all, I was having some technical difficulties. Apologize for the lateness. Let's go ahead and I guess get it started, shall we? Let's see. Let me get my stuff ready. Whoa. Okay, cool. One second, let me get my chat client set up. Interesting. Okay, I don't know if that's working. Let me make sure I got that. That's great. Just do this. All right. Oh, need to change the title again. All right. Cool. Let's go ahead and TypeScript. There we go. Let's go ahead and get started. So today is a big session in terms of I guess material and also hopefully the growth to your skills, because this is the introduction to TypeScript, and I think TypeScript's been something we've been talking about a lot, throughout our bootcamp here, and the day has finally come where we can kind of talk about it and get to see it in action a little bit. So I'm going to go ahead and go over to the agenda. Also, make my screen bigger. Cool, there we go. So first off, what is TypeScript? TypeScript is a programming language, and the easiest way to think about it is it's JavaScript combined with the type system. It was invented by Microsoft in 2012, and it's gotten really popular in the past few years, especially. Before TypeScript, there was this language called CoffeeScript that was super popular. So it's not like it was the first of its kind, but for some reason TypeScript just really took off, especially recently. So why use TypeScript? I would say there's three main reasons, and the number one reason I would say is that it reduces the chance of unexpected behavior in your code, which means that you get less bugs. Another big thing is that it also makes you more hireable as a developer, especially since more companies are hiring it for it these days. Especially, I see a lot of startups, VC-funded startups or bootstrap startups that are hiring for TypeScript roles. So that could be an advantage there. It also just helps you build production-grade projects faster, especially if you're already a full-stack JavaScript dev. And this is mainly because you can now use type-safe tech stacks, like the T3 stack, which is what we're going to kind of walk through today at the end of the session. And basically before I have a whole slide dedicated to it, but basically what this means is that you can use the same type definitions in your client, in your server, so that both the client and the server know exactly what the data looks like that is being passed around. So this may not sound like much, but this is kind of this is a huge thing, trust me. Cool, so we'll get more into that later. So another thing I want to say up front is that there is kind of a ramp up period when you're learning TypeScript, where you struggle through a lot of TypeScript errors for a long time before you really start to get a hang of it. And I definitely faced this myself. I think I wrote JavaScript for maybe 5 years before I started learning TypeScript, and even then, it was pretty difficult. There were a lot of things that were very unfamiliar to me, but overall, looking back on it, I can confidently say that learning TypeScript made me a lot stronger of a developer. It was probably one of the biggest growth spurts I feel like I hit in the last couple of years. But yeah, so I think this ramp up period is pretty normal. It seems pretty common that people have reported something similar, and I think overall you'll hopefully be rewarded at the end of that struggle period, and you'll be rewarded in the sense of you'll just be a more confident, stronger developer, which is always good, right? So why, continuing on the last side, talking about like why use TypeScript over JavaScript, like a very easy way to visualize this is that TypeScript basically reduces the amount of uncaught errors that you have in an app. And if we think about apps, right, like the more big the app, like the larger the app, the more chance you're going to run into like weird errors, right? Unexpected errors. That's just like a natural thing that happens. So just by using TypeScript, your users will just have a much better experience. Like they're going to experience less of these errors themselves. And one of these examples is, so on the top here, we have JavaScript, right? So I should have labeled this, sorry, but this is JavaScript. So in the JavaScript snippet, we have a definition of an object with a height and width attribute. And then we have a variable called area, and area is equal to the width times the height, right? There's a typo here, right? That's on purpose. And it's basically showing you that JavaScript will just go ahead and run this code no problem, right? Right? JavaScript doesn't care that this is misspelled, right? It doesn't really know that. It's just like, okay, you want a key on this object that doesn't exist? Sure. So that's what JavaScript does. And with TypeScript, if we put the exact same snippet, let's see what we have here. So you have the same thing on the top, right? The same object. And then in our area, we have the same code. But as you can see, TypeScript underlines the misspelling and reminds you like, hey, this property, it doesn't exist on this object that you defined. Did you mean this spelling? I mean, that's a huge one already, right? Even if it was just for this one like feature of TypeScript, I might want to use it just because I can't even count the amount of times I've made like spelling errors on variables, and it took me like way too long to figure out that it was a misspelling when you have like a ton of code. So yeah, just for this alone, this is a huge advantage. But basically, this is an example of TypeScript's ability to infer types. So what's going on here is that TypeScript knows the type of this object because it saw you define it right here, right? It saw from this definition, it inferred that, okay, this is an object with a width and a height property. So when it came to running this line, it can just check the type and see, and it's very clear to see that, oh, this key that you're calling doesn't exist on this type that you defined. So TypeScript has the ability to automatically infer types, like what's going on here. But most of the time in the real world, you're going to have to balance that with defining your own types, because sometimes you're going to know more about the type than TypeScript will. And we'll see lots of examples of this in a second. But yeah, in short, the TypeScript philosophy is that it's better to catch errors in development than let your users experience them like on their end, right? So another way to rephrase this, I guess, is it's better to suffer now than to suffer later, right? One of the struggles of using TypeScript is that you're going to be kind of racking your brain a little bit longer when you run into errors, because sometimes you're going to run into weird sounding TypeScript errors that take you a long time to debug. But the idea here is that that's the trade-off. That's the temporary trade-off you pay in order to guarantee that, not guarantee, but like greatly reduce the amount of potential errors that your users will run into. So I think thinking this way is also helps you become more senior of a developer too, right? Because like I think a lot of when you're a junior developer, you're just like, you're just starting out trying to grow your skills, and then as a senior, you start to kind of like take in more realms of responsibility, and one of those realms of responsibility is like product, right? So caring about like users and stuff like that. So I think this is generally a good philosophy to have. Okay, let's talk about some downsides really quick of TypeScript. So yeah, as I keep mentioning, there's a steep learning curve to TypeScript, right? This session is just one session just to introduce you to TypeScript, but really like your learning TypeScript will be a continuous thing. I don't know, you'll have to be a developer for a really long time to say like you've learned all of TypeScript and mastered it. But like I'm on my second year of using it, and I still feel like I have a ton to learn. So that's why resources are really important, which we will show at the end. And yeah, the number of third-party libraries that are available to you are actually more limited if you use TypeScript. So this is because when you use npm to install something, if your project is using TypeScript, then you kind of have to use libraries that also are TypeScript friendly. I mean, that's actually not a 100% true statement because there is a way to kind of get around this. If you want to see this article, it'll give you like how to do that. And I've had to do that like a handful of times, like maybe once or twice per big project. I'll have to like create an empty types definition for every like non-TypeScript npm library I want to import. So it hasn't been like a huge blocker to me, but you should just know that like, dealing with third-party packages is a little bit more painful, I guess is what I'm trying to say. So to create a new TypeScript project, So to create a new TypeScript project, or if you want to update an existing JavaScript project to TypeScript, you need to meet these following conditions. So first, you need to have a tsconfig.json. You might be thinking, oh my God, like another config file. And yeah, I don't have a good response to that because that is exactly what it is. It's just another config file. And this one, unfortunately, might be the most confusing one of all. So just a heads up there. I linked an article in the TypeScript documentation about the tsconfig if you want to read more in depth. But this deserves a whole talk on its own. So I'll just leave it at that. But thankfully, you don't have to touch this that much, usually. So the other requirement is that your files have to end in TS or TSX. So TSX if you're using JSX, right? If you're using React, your file endings might be TSX. You also need tooling that is going to transpile your JavaScript. It's going to transpile your TypeScript code into JavaScript so that it can be read by the HTML, right? The HTML unfortunately doesn't yet understand TypeScript natively, so you need something that will translate the TypeScript into JavaScript so HTML can read it. And yeah, so basically all of these requirements in the real world, you usually won't be creating all this from scratch, right? This is a common pattern that we've run into picking up these new technologies. Like we usually don't create it from scratch in the real world. So most of the time when we were building projects or working at companies, whatever, we would use like a framework template that would package everything together for you so that you don't have to like set it up yourself. But it's still good to know kind of how it works. Okay, cool. So let's take a quick break from the slides and dive right into kind of a quick demo of TypeScript in action. So here in this code sandbox link, I think it links to a sandbox of a Node TypeScript project, I believe. So this is just using Node.js in TypeScript, right? No React, nothing like that. It's just Node, but with TypeScript. So let's check that out. Okay. Cool. So I should spin up this code sandbox here. All right, let's give that a second to initiate. I guess in the meantime, we can poke around these files. So let's take a look at what an example tsconfig will look like. So basically the main parts of the tsconfig are the compiler options key, the include key, and the exclude key. So let's talk about include and exclude first. So include basically tells TypeScript what files do you want to actually include in TypeScript. So this basically will usually point to your source folder or like whatever folder you have that contains your all your TypeScript files. And an exclude is like what files should we not like kind of bundle and transpile together. And so generally this is like third-party libraries, so that's why you have node modules here. And I guess sometimes tests maybe you don't want to include. Let's see what else. Okay, cool. And then for compiler options this is the tricky part of tsconfigs because they're so varied. Like every project kind of has like a different style. It appears like I'm sure there's a right way to do things, but I don't know. I personally am still wrapping my head around like the millions of options here. So for this, I will just say like I largely defer to what the project has chosen, since usually they're opinionated for whatever stack they chose, so it works fine. But yeah, generally you don't have to touch this file that much, but it's just good to know kind of what goes on in it. Okay, so the file's actually loaded now, or sorry, the project's actually loaded now. So let's take a look at the only real editable file here for us, and that is the index.ts. So this is a blank TypeScript file. So what I want to demo here is, so let me just demonstrate another example of inferred types, but using an object. So let me go ahead and, move my mic. So let's define a user object. Let's pretend we're like building an app and we have a user object somewhere, and maybe our user is like name Zach and then age, let's say 26. So yeah, this is like our user object, and to see TypeScript in action already, you'll notice that user is underlined for us in yellow, right? So yellow usually means like a warning or something like that. So we hover over it, and so it tells us right here, it's inferred the type of user, right? It knows because we defined it like this, that the type is name or age. So the warning it's basically giving us is user is defined. I don't know why it disappeared, but the error or the warning it was giving us was user is defined but not used. So it's basically saying like, hey, you defined user here, but you're not using it anywhere. So the warning, I keep saying error, the warning will go away if we do something with it. So just something as simple as like console logging it. And then the warning goes away. So basically this is an example of inferred types, right? Because user, because it's defined once, like statically like this, it's pretty easy for TypeScript to like understand what the types are. So another thing to mention is that, so this is a string type, right? So it goes in the user object and it understands that name is a string and that age is a number type. So I'll include a list of all the types like back in the slides when we go back there. But for now, let's just continue on. Let's see what to demonstrate. I guess the thing to, one of the things we usually do in the real world is for objects, especially, we rarely let TypeScript infer them ourselves. This is usually just because objects, when we use them in real apps, like they're always being used with like data and stuff, like maybe API calls and JSON and stuff like that. So generally, like TypeScript doesn't do a fantastic job at inferring the types from objects. So in the real world, what we usually do in this situation, or maybe a good example is like a user's array. Yeah, this is like more like a real world example, I think. So if we have a user's array that looks like, let me go ahead and make this really quick. All right, I'll just do like 3 users or something. Okay, and then I'll change their names. Dak. Okay, something like that. So we have our users array, and now let's see if it knows the types. Okay, it does. It does know that the type is a list of objects, as you can see here. So this is how TypeScript like shows that it's a list, right? It puts the type before those square bracket symbols. So let's say we don't know what this data looks like maybe it's coming from an API that we don't know the type structure of. How would we kind of let TypeScript know that this is the correct type? So in TypeScript for objects, we define either an interface or a type. And they're basically the same. There's one difference is that interfaces can be extended, which means they can be changed after they're defined, and types can't. But besides that, they're pretty much interchangeable. So just use whatever like style your current code base is using. So in this example, let's just use type. So basically what we would do here is we would define a type to represent, define a type to represent each object. Like each of these objects, we want to define a type for. So we could say type user. So user would be the name of the type. And generally, I should mention this earlier, but generally types that we define ourselves, like developer defined types, we capitalize them most of the time. So type user, and then we can say equals bracket, and then now we define our type. So we can say name colon string. I think it's comma, right? Yeah, it's string, and then age colon number. So notice that this isn't an object, right? This is not an object. It looks like an object, but if it was an object, then this wouldn't work because, you know, if these aren't variables, like they have to be defined somewhere, right? The object won't just let you write the word number without like quotation marks or having it be defined. So this is a new kind of data type that allows you to basically define other types. So meta. So essentially what you do here is like once we define our type of user and we want to explicitly tell TypeScript that this is our type. So in this example, TypeScript has already correctly done it for us, but let's just pretend that users is coming from an API or something and TypeScript doesn't know. So in situations like that, you would have to explicitly give the type to TypeScript. And the best way to do that is to, on the variable here, const users, you would put colon, and then you would put the type that you want to assign to this variable. So in this case, it's an array of users, right? It's not just one user, it's an array of users. So we can write the type that we just defined, so user, and then we can put square brackets, and yeah, cool. So now it works correctly, I think. It's just upset that we're not using users again. But essentially that's the, let me just invoke it really quick, like users.age, or actually that's not gonna work, users.0.age. Okay, cool. So now, as you can see, it's changed the definition, right? If you've noticed, before it explicitly showed what each user looked like, now it's like, okay, this is users is equal to the developer defined user type. And as you'll notice here, let's go through this again, actually. So if I console log, if I want to console log the first user in users, I could do like console.log users at 0. And if I want to console log their age, you can see that just by pressing dot, my editor here has used IntelliSense to infer like which one do you want, right? Basically like kind of pre-fills them for me. So it makes it impossible to do a typo, right? If I do a typo like GE, you know, it gives me the red error saying that, hey, there's no property named GE here. So it's pretty useful. Excuse me. Since so much of using like data types in the real world is dealing with like nested arrays, nested objects, to be able to have it all like safe for you is super, super valuable. Okay, so let's hop over back to the slides. Okay, so as promised, sorry, let me drink some water. So as promised, here's the list of all the types. I think this is all the types. Someone at some point should correct me if I'm wrong here, but I wasn't able to find any more upon digging. So of course, you do not have to memorize all of these, but let's just do a really quick like run through of what each of these are. So, you know, string, Boolean, number. I think y'all should be like fairly familiar with those. Like strings are just like words or like text. Basically, Boolean is true or false. Number is, you know, integers or floats, etc. Oops, I put string twice. Didn't mean to do that. The next one we have is array. So an array is like a list of something. Tuple is basically just a list, but containing 2 items. So it's a kind of like special type of list. Enum is an interesting one. Enum is basically like whenever you would want to present options for something. So what I mean by that is like if you have a user and you want to set like what country they're from as a property, you could use string, right? When you just have the country listed, but like we know all the countries in the world, right? There's a kind of like it's technically not a fixed list because it does change over time, but for the time being, like you can put all the numbers, all the countries on the list, right? And if you have an enum in this situation, it would basically prevent typos from happening on the country, right? Let's say someone types Australia but like enters it wrong, in our data, that would be counted as like a different country, right? Because it's misspelled. But an enum basically forces the values to be within a range of like options. So we'll try to give an example for this at some point, but that's the easiest way I could describe it. So unknown is basically an unknown type. So in situations in TypeScript, you're going to not know the type. And basically the two ways to deal with a type you don't know, like the easiest example I can think of is a third-party library, right? The code that you did not write. That is usually when you have to deal with unknowns and any's. So if it's code you did not write and you need a type, but for some reason you just don't know it, you can tell TypeScript, hey, the type is unknown. Most of the time, people use any. Any is kind of like the get out of jail free card in TypeScript, right? It's basically, there's so many jokes about, oh, if you are running into an error that you can't solve in TypeScript, just throw any at it and then you'll be good. I do not recommend doing that at all. Like that is not a good practice. That's kind of like a cop out. Like it kind of defeats the purpose of using TypeScript if you're just going to kind of put any after everything. Instead, if you do ever come into this rare situation, I encourage you to use unknown instead. Cool. So I see we have a question in the chat. Sorry, don't mean to ignore you, but I can go ahead. Yeah, if you don't mind sticking around, I'm happy to kind of answer that question after. Just really trying to get through all my slides right now, but definitely interested in answering this one. All right, cool. So back to the types really quick. So we have void. Void is basically just like, I think void is equal to null or undefined. So it's kind of one type that encompasses both. And then we have null and undefined individually. We have never. Honestly, I never use never. So I don't have a great idea or great like grasp on what exactly does. We should probably look that up at some point. But yeah, sometimes I see libraries use never. But if anybody knows, you're free to drop it in the chat. And then finally we have object, right? Objects are just object. But this is another one that I don't feel like is used often because in our example we just showed, you usually use like types or interfaces, right, to define objects. So, sometimes you'll see TypeScript infer something as an object, but very rarely. I can't say I remember it very often. Okay, sorry. So this is a type versus interface. We kind of mentioned this already, but when to use either, they're pretty much interchangeable, like in terms of what they do. You just basically want to stay consistent with your current code base and style. The only difference is that interfaces are extendable after you create them, and types are not. So, take that as you will. I personally, I am team interface, if that makes a difference. But honestly, like I don't know why. I started using interfaces because I used the code base that used them, so it just kind of stuck with me. Okay, so now that was all kind of like theoretical stuff. Now let's talk about some practical, like application building stuff. Because in my opinion, that's the best way to learn TypeScript, right? We could talk about like the definitions in the handbook all day, which I still encourage you to go through and check out the TypeScript handbook. It's really good. But, in my experience, the best way to learn something is to just like use it. So that leads us to the T3 stack, which is a pretty popular stack right now, to be honest. But it's something I don't think a lot of boot camps like are teaching yet because it's pretty cutting edge, but I really like it. And this is my personal favorite framework, and it is basically designed to be used with TypeScript. So it's a highly opinionated, 100% type safe, full stack development tech stack. When I was writing the sentence, I kind of laughed because it was just so like, I don't know, kind of buzzwordy and lots of hyphens. But basically what this means in short is that your client, so your front end, knows exactly what the data in your database looks like. This may not sound much, but if you think about it, pretty much most apps that you will write involve taking data in the database, moving it to the front end, and then vice versa, right? And so many errors happen when you write code that doesn't line up between the two, right? So basically your whole code editor and your whole code base is aware of exactly what the data looks like in the database, which is super valuable. It was popularized by Theo. Theo is a He's the CEO of Ping. He's a YouTuber. He's a Twitch streamer. He's a really good skateboarder. Basically, he's better than me in every way. But he has this really funny YouTube channel as well that I encourage you to check out. But yeah, I believe that he was the guy that really like popularized the stack. And it's called the T3 stack because the three T's, I guess, are Tailwind, TypeScript, TRPC, Next.js, Prisma, and NextAuth. So you might realize that we've actually talked about most of these at some point, right? Like last week, not last week, on Tuesday, we talked about Prisma and NextAuth. For a couple weeks back, we talked about Next.js. Now we're talking about TypeScript. We introduced Tailwind very early on. So basically all this time I've been leading us to getting up to TypeScript and the T3 stack because I really think it's going to improve your developer experience. And I know the only one we haven't really talked about here is TRPC. And just a really short blurb on TRPC. So TRPC is basically an alternative to writing backend endpoints. So in Next.js, right, if you guys remember from our Next.js session, in our pages directory, we had like an API directory, and that's where we would write backend endpoints, right? So TRPC is basically an alternative to writing those endpoints. And the best way to describe it is TRPC is like, it's a lot better with TypeScript than writing backend endpoints. It's fairly new, so I would say it's definitely more risky to use, but it's pretty trivial to move off. So I think it's worth learning even if you are still trying to get comfortable with the backend space. I don't think learning TRPC is a cheat code at all. I don't think it's will simplify it a lot. So generally use one or the other. Use backend Next.js auth endpoints or maybe an Express server endpoint, or you would use TRPC. But I would say TRPC is easier to pick up than the standard backend endpoint like REST API. So I do encourage you to check it out if you do have time. So I guess we'll spend the rest of the session today. How much time do we? Okay, good amount of time. We'll spend the rest of the session today kind of walking through the T3 stack. So we'll clone the template or the repo onto our computers. And then we're going to just walk through the stack and maybe play around with how TypeScript works and how it helps us here. So let's click on this link. We'll drop it in the chat because I realized that you cannot click links through a stream. Okay, so yeah, before we clone it, let's kind of just run through the repo. So create T3 app, interactive CLI to start a full stack, type safe Next.js app, and then give you the command to install it. So yeah, Theo has a full video on it that I encourage you to watch. It's pretty entertaining. So we already talked about this. Oh yeah, let's just go through the axioms really quick, the principles they follow. So the first one is that they don't overload you with technologies, right? This is, in terms of tech stacks, this is actually not that dense. Sometimes tech stacks are a lot longer, where these templates come with a lot more technologies. But I guess one of the axioms of T3 is just you only add technologies that solve problems. So everything that's added here is the bare minimum, essentially, is what they're trying to say. Bleed responsibly, which is basically use whatever is bleeding edge as long as it's as long as you do it responsibly, right? It is riskier to use something that is newer, right? Especially in web dev when things are always changing. But they're making very opinionated bets. They've watched these technologies, they have seen the massive benefits they bring, and then they just decide to, it works well with the stack, so they add it. That's what they're saying here. And yeah, and this is what they're saying about TRPC. They think TRPC is one of those newest technologies on the list that I presented. And they're basically saying that they bet on TRPC because it's just functions really, and it's pretty easy to just copy those functions and move them to an Express web server or a Next.js backend or something like that. So in my opinion, this is the key axiom from T3. The reason why I like it so much is that type safety isn't optional. You have to use TypeScript and you have to use complete type safety if you're going to go down this route of using the T3 stack. And I think that's a good thing because once you get used to TypeScript and full type safety, it's just so hard to go back. It's like I can now write apps without the fear of some user waking me up with an angry complaint that they made a payment and it didn't go through, right? Because I had a JavaScript error somewhere. I mean, nothing that dramatic is likely going to happen to you, but it just basically makes your life easier as a developer. Even though it is harder at first, in the long run, it makes it easier. So yeah, I think that's a great tenet to have. All right, so let's go ahead and, oh yeah, they have a Discord server if you want to join. It's pretty active, so do check that out. Let's go ahead and get it on our computers. So I'm going to copy and paste this command for the T3 app. Go ahead, open up Hyper. I'm going to go ahead and go to my Bootcamp projects folder. All right, let me go ahead, make this bigger. I feel like the size of Hyper, I guess, resets every time I close it. All right, so let's go ahead and paste in the command. Whoa. Need to install, yes. Okay, all right, so now you go through their fancy little CLI builder or whatever. So what will our project be called? We'll just leave it as is because I don't know what we're building yet. Will you be using JavaScript or TypeScript? Okay, so this is a funny one. Let's see what happens if we choose TypeScript or JavaScript here. Wrong answer, using TypeScript instead. That's pretty funny. I've never seen a CLI tool do that. I respect it. Okay, so now this is what packages would you like to enable. So this is what you want to choose to include in the boilerplate, which is kind of nice. So honestly, because let's not talk about TRPC yet, so we'll leave that off. We definitely want Tailwind, definitely want Prisma, definitely want NextAuth. So let's just add those and click enter. Initialize a new Git repository, sure, why not? Would you like us to run npm install? Yes. Okay, so now it's going to install everything. Okay, all right, while that's getting ready, I'm going to go ahead and open up my editor. And then we'll open this project. And then we'll do a really quick walkthrough. Okay, cool, so it's done, nice. So yeah, we have to do the same thing that we did on Tuesday, with our Prisma database, right? If we want to push up any data. So we have to do that before we actually spin up the app. Let's go ahead and open up our terminal here, make this full screen, and then open a terminal here and close the one here. Copy this command first. Okay, let's go ahead and just let's run this Prisma command to push up our DB. Okay, all right. And then we'll run, I guess we'll just spin up the app first, npm run dev. After we spin up the app, we'll take a look through the code base. All right, so let's just take a look at what app this is first. So localhost 3000. Okay, cool. So this is what they give us. Let's see if we have login. I think we do. Oops, that's not how you spell login. Wait, that's my app. Login. Nope, there's no login. Okay, never mind. I thought it came with the login page. Whoops. Okay, let's just, before we begin, let's take a look at the tsconfig. So that's what I mean by the compiler options. Like, there's just there's a lot of these properties, and it's kind of difficult to explain each one. So for the most part, I don't touch whatever the template comes with, but we do need this tsconfig in order to have TypeScript work. I guess we'll start in the front end. So let's go to the source folder and go to pages, right? This is all just Next.js file structure stuff. So let's go to pages, go to the home page. So yeah, this is everything we see on the home page. I thought there's like a login page, maybe not. Cool. So as you'll notice here, let's talk about the front end. I guess this is the only component we have. So let's talk about how this TSX file is different from the JSX files that you all have been used to. So one thing you might notice here is that on the home component, there's this weird colon syntax, right? In JavaScript, like usually it's just like this, right? But in TypeScript, if you want, you can explicitly type functions, right? In this case, home, the component, is a function component. So if you want to type it, and this is optional, by the way, you don't have to do this, but I think for Next, this is like best practice. And you can basically import the third-party type from Next. Next is saying like, hey, we defined this type for you since you're using our framework. So we can basically import it here and assign it to the home component. But honestly, I don't do this like every single time. This is kind of optional, but I think it is best practice for Next.js. So everything else here is the same. Like nothing else is different here, as you'll see. But where I will say in the real world, like in most projects where TypeScript and React really kind of like interact with each other, is when you use state. Like let's say we just create a little state variable here called name, set name equals use state. So when we use state, sometimes you can, if you want use state to start out null, you can do this, right? But check out like how TypeScript types name. It says name is undefined, but we don't want name to be undefined. We want name to be string, right? So this is an example of when we, the developer, know more about what we want than TypeScript, right? TypeScript has incorrectly inferred for us that name is undefined. I mean, it's reasonable to see why TypeScript it does this, because we don't have anything in use state. But what if we want name to be equal to undefined, or like a null variable or a string? So this is an example of when we would want to explicitly type. So basically, when you use state, you almost always want to explicitly type as a best practice. But I mean, maybe there are lots of situations where you don't have to. But here in this example, if we want this situation where name needs to be equal to either string or null, we can do this. We can say, we can put this like angled symbol, or like the less than caret, put that there after the use state function, but before the parentheses. So use state, and then we say string, because we want name to be either a string, or, so we put the pipe symbol, and then we say null, and then we close that up there. So now if we hover over name, you can see that, okay, name can be either equal to either string, null, or undefined. So I made a mistake because I put null, which added that to TypeScript's list here. But I guess if you don't have anything at all, it actually isn't null. Technically, it's undefined. I know it's confusing. It is weird, but we just have to play by the rules here, and instead just be like, okay, I guess we don't care about null. Since this empty state is just undefined, we'll make it undefined. And now, if you can see, if we hovered over name, we get what we want, right? Name can be equal to string or undefined. So anyways, all of this was just a long-winded way to say, when you use TypeScript with React, use state is when you're going to kind of like run into this typing thing the most, I think. Another example of when you would very frequently use types in React is when you're defining functions, right? Whenever you have like a form, usually you have some function that like handles submit, right, after you submit the form. So let's pretend we have like a handle submit function, handle submit. And then actually, I'm gonna do it like this. Const equals oops, I messed this up. Something like this. Like we have a handle submit function, and let's just say hello, and pretend that we're doing something here. So I'm gonna create a form on in the app here, just a random form. I guess I'll just add a input. Well, I guess I don't need an input. I'm just going to add a button that submits it. Submit. Okay, so this is all to just demonstrate when you would use types in functions here in React. So say in this form we have this onSubmit, right? And then we want this to be equal to the onSubmit, the function that we defined up here. So let's say onSubmit. Yes, that's right. Or sorry, handle submit. I mistyped it. And remember that whenever we submit a form in React or any single page application library or framework, we usually want to prevent the default behavior, right? We're always writing e.prevent default, right? So let's say you want to do that in this function, right? You want handle submit to take in e as a parameter because it's getting, called here. Like anything in on submit will take in the e like event parameter, right? So let's say we want to get that in here. So we can maybe type e and then say e.target, or sorry, not target, e.prevent default. Oh wait, there's no IntelliSense for us. It's not autofilling, right? Why is that? Well, if we see, we can hover over e, and in TypeScript's angry, it says, hey, parameter e explicitly has an any type. This is what happens when you don't define a type for the parameters of a function. That's one of the main situations where you're going to have to deal with these TypeScript errors. So to get around this, we have to explicitly say this e is equal to the event that's being passed in through the onSubmit. You might think like, oh, TypeScript should know this. Well, I guess, but it doesn't, right? TypeScript doesn't know that this is the same e that's being passed in through here. So that's something you have to handle yourself. So typically what we'll do here is I think we do like a mouse event, like React mouse event or something. Or maybe it's like submit event. I think if you start typing like event, like submit event, you'll get something autofilled. But let me see if there's like a React submit event. I don't remember the exact one, but this is like a common situation that you'll usually like Stack Overflow. So we can just take I just want to make sure I have the right one. So submit event React TypeScript. This is how I usually deal with these like function errors when it's a type I don't know. So I just Google it and it says, let's see. Wait, I want to handle submit. Submit event. Forms and events. Don't submit. Oh yeah, here we go, I think. Okay, React.synthetic event. Okay, so I guess this is what they consider as best practice, maybe. So we can use React synthetic event. React.synthetic event. Okay, cool. So now it's happy. So now it knows that we can, if we delete this and type this over, see now we have IntelliSense. So it knows all the functions on event for us. So yeah, basically between use state and handling functions, that's like when you would deal the most with types. The third example I would say is with props, right? When you're passing props in between components, that is when you'll frequently have to deal with types. I wonder if we should do some now or maybe just leave that to the homework to solve, because I do want to make sure like we get through everything. Well, I don't know. Okay, let's end it with the props, and then I think we'll have to continue this in another session because yeah, I don't want to like overwhelm, and I feel like it has been a lot already. So hopefully if that's cool with everyone, we'll just stop on the front end side of things with TypeScript, and maybe you guys can explore a little bit of the back end, but we'll probably have to pick it up in another session. Okay, so let's end by talking about props, which is like the third most common way that you'll have to deal with TypeScript in React. So in props, basically, if you have another component, so let's say we have, I don't know, the header component. It's a pretty common component. Next page, because we want to follow the style of the code base. Okay, so const, actually we don't need a const. We can just return a header and just be like, I don't know, this is a logo. Something like that. Okay, so let's pretend we have this component. Maybe we'll actually just have the, let's have a next, or the header, basically take in props. Let's say we just wanted to say like whatever is passed into here. So maybe we can call the props, I don't know, title. And then we want to get title from here. But TypeScript's not happy. So why is it not happy? Because title blank is not equal to React node. Okay, so basically the props that you've passed in here, they have to be within an object, because React, like by telling React, like, hey, this is our next page, it already knows that there are certain props that are built into React, like children, stuff like that. So we basically have to put our props in an object, and even then, it's still angry. See, it said property title does not exist on type empty object, right? So this is another example of when we have to explicitly type, when we have to show TypeScript what the correct type is. So after the object here, you would typically go like this. You would go like colon, another object, or curly braces, I guess is not technically object. And this is where you define your type for the whole object. So in this case, the type is, it has a key called title, and title is equal to the string property, or a string type, I mean. Okay, cool. What did I do here? Oh, I guess we can't use next page if we're defining our own. Oh, wait, sorry. I guess next page is only for the page itself. I realized that we don't want to use next page for the header because the header is not a page, right? The header is just a component. Whoopsies. Okay, so now we're good. So now TypeScript is happy. It is satisfied that we are no longer, doing bad. So let's say now we can here we can just pass in header in our code. So let's just put header like here or something. And now we know the type, right? The type is title, and it even autofills it for us, right? So it autofills title, and it even knows that it's going to be a string, right? Because it's already pre-filled it with these, these quotes. Oh, I didn't even know it was going to do that. So now it's very hard to write something incorrect. So like, if you thought title was like a Boolean or anything else, TypeScript literally won't let you make that mistake. It will prevent you from making that mistake. So that's nice. So you can say woohoo. Yeah. Okay, cool. So that's kind of like a fake example, but basically what I want to illustrate is that these are, in the real world, these are kind of like the three most common ways you're going to end up dealing with TypeScript if you're in React. We have other things to talk about when we get to the backend side of this, but for now, I think that is a good stopping point. I think we covered a lot today, and yeah, I definitely don't want to overwhelm. So we'll pick this up in another session. I'll leave you with some resources as well, because resources are especially valuable when you're learning something as deep as TypeScript. So I think the two best resources that I found is one, this guy named Matt Pollock. He has a YouTube channel. Do check him out. His videos are pretty amazing. They're definitely they're designed for beginners too, but they're really good from getting from beginner to intermediate to advanced in TypeScript. So highly recommend. He even built this VS Code extension that translates TypeScript errors for you, right? Remember how I said TypeScript errors is that's how you're going to struggle through it, just by running into errors and then trying to figure out what those errors mean. Well, he built an extension that actually translates the extensions to in plain English, which is really nice. So do check that out. And finally, the official documentation for TypeScript is actually amazing. It might be one of the best documentations that's written for such a huge lofty topic. So yeah, I would say it's really great even if you're starting out to read documentation for TypeScript. And I included a link to that here. Okay. So finally, oops, I didn't upload this image, but finally the homework is to basically catch yourself up with the TypeScript module on the Playground app. And if you don't have enough time to do that, if you want, you can also just watch the crash course from Matt Pollock, which is a 23-minute beginner to intermediate crash course, and it's really good. I learned a ton from watching it recently, and yeah, like I said, I've been writing TypeScript for 2 years, so it's very valuable. And he packs a lot of useful information in there. All right, that is it. And I know you've been waiting for a really long time, Busy Metal, so I really appreciate that. But if you're still there, I can definitely get to your questions. So, let me get that water real quick. Okay, so I've been meaning to ask you, let's see, would you tell someone that's had a look at the coding capabilities of AI and feels scared and discouraged on their journey, on their learning to code journey? I'm of the opinion that AI enhances us and the tool should be an even bigger incentive to keep learning or start learning. I 100% agree with you, Busy Metal. That's exactly how I feel about the situation as well. I do think that right now, at least, AI is fantastic as a tool for developers, especially new developers, right? I use GitHub Copilot, which is the plugin for VS Code that basically auto-completes code for you. And I do sometimes wonder, is that making things too easy? Ultimately, the AI still is going to make errors for quite some time, right? So you still need the ability to code to be able to undo those errors, right? I don't think anybody can build a real production grade app yet using only Copilot suggestions. Chances are it's going to be wrong still, a good amount of the time. But who's to say it won't get better? Even then, I do feel like it's still really important to learn how to code right now, um, even if the risk of like full automation comes about. Because I think learning the program and learning like software engineering, it kind of changes the way you think too. Because you think you're able to solve problems a lot better generally. I don't know if anybody else feels this way, but I have this like thought for a while where it's like, yeah, learning software engineering teaches you a different way of thinking, which is useful in domains outside of software engineering. So I would say for that alone, it's still worth learning to code. And it will be I personally enjoy the use of these AI tools right now for coding. They help a lot. And I can see that there's still quite some ways to go before that we're like totally replaced. But who knows? AI moves quite fast, but even then, I'm still pretty optimistic that coding is still an incredibly valuable skill to learn. All right, cool. So let me know if there are any other questions in the chat. I know today was a little bit longer. Thanks for hanging around, everyone. If you're still with us, but yeah, no, for sure. Yeah, thank you for the question. Thank you for being so patient as well. It's really really interesting thought. All right, y'all. I think I'm going to probably have to hop off for today. But yeah, thank you guys so much for joining. I think I'm also going to start focusing a little bit more on YouTube. Like, I'm not going to restart the whole session, but I am going to go back and kind of edit and re-record a lot of the sessions the past sessions that are on YouTube, because yeah, I realized that I should just invest a lot more in YouTube. I've been focusing kind of more on Twitch, and yeah, hopefully that'll be helpful when it comes time if you guys go interview for jobs and you guys want to review some content. Hopefully that'll be a better option for you than just watching like 2-hour straight streams. All right, cool, everyone. Thanks for hanging around. Hopefully you guys didn't find this too overwhelming. That's my main goal. Even if you do find it overwhelming, just remember that like this is just this is a big step in your kind of web dev progress, and it might be daunting, but I promise if you kind of spend a long time with the T3 stack especially, and you start to build real applications and just ship things with it, it will come to you so quickly. It will come to you a lot faster than you expect. So that's all I have to say there. But yeah, thank you guys so much for joining, and I guess I'll see you guys Tuesday, right? I think Tuesday is when we're going to build an AI app. I think our second AI app so far, and I think we're going to do it with DALL-E or Stable Diffusion. I still haven't decided. I will let you know which one I decide, but we're basically going to try to build an AI app together, and we're going to use everything that we've learned: TypeScript, Tailwind, Next.js, the whole shebang, in the form of the T3 stack. So all right, y'all. It's been good as usual, and I will see you on Tuesday. Take care, everyone.